Next, we're going to look at section 1.2, more definitions. So chapter 1 is very definition heavy, and they're definitions that we're going to use throughout the term. And this time we're going to keep looking at data and look at different types of data. So in section 1.1, we really focused on population versus sample, and then also descriptive stats versus making inferences, right, as well. Here we're going to look at the data again more closely and look at different types of data. So the first thing we see here, we have two main types of data beyond like just population or sample. So let's say we have our sample data. There's different types of sample data and there's different types of population data. So it's either qualitative data or quantitative data. Qualitative data consists of things like attributes, labels, or non-numerical entries. They don't have to be, they could actually be numbers too. We'll talk more about some examples with that, but they really represent things like attributes, labels, names, things like that. So there are things that we don't normally think of adding together or multiplying or finding the average of. It kind of wouldn't make sense. For instance, think about qualitative data. Let's say I asked in class everybody's favorite color, right? So let's say your favorite color is blue, that person's is red, the next person's is green. Does it make sense to add that? Right? How do you add red plus blue plus green or find an average? That's qualitative data. Quantitative data are data that consists of numbers that are measurements or counts. So not only are they numbers, but they actually have real numerical meaning. Like we could add the numbers together and it makes sense. Or we could find an average, it makes sense. Things like that. So not only do you have numbers, but it actually makes sense to work with the numbers like we normally do in mathematics. And again, we're going to look at a whole bunch of examples here. So we have one first example. This is from page 9 in your text. I just copied it in here. And the table shows sports-related head injuries treated in U.S. emergency rooms during a recent 5-year span for several sports. So which data are qualitative and which are quantitative? And like I mentioned, most of our examples in the text are real-world examples, real data. So here you'll see the source. So if you go to your text, you can see the source for our different examples. So here we see that for basketball, there were almost 132,000 head injuries treated in U.S. emergency rooms. For baseball, around 83,500. Football in the lead with 220,000, and so on. So what we see here is this left column, the different sports. This would be qualitative data. Right? The different types of sports. So we could ask a question like, well, which types of sports do we usually see having head injuries? Well, here are 1, 2, 3, 4, 5, 6, 7, 8, 9 different sports that have quite a few head injuries that get people sent to the ER. The numbers on the right, this is your quantitative data. So these are measures or counts. These happen to be counts, right? How many occurred? So 131,930 occurred in basketball. 83,522 occurred due to baseball, and so on. And beyond that, it actually would make sense to work with these numbers, right? We could find the average number of head injuries for these sports. We could find the one that had the most, right? So 220,000 here. We could subtract the values or add them up to find the total number of head injuries. So it actually makes sense to work with the numbers. So that's actually part of quantitative data as well. Not only are they numbers, but it actually makes sense to work with the numbers mathematically. So here we have two examples of our different kinds of data. All right, so let's do a few more examples. This is example 2. This is not from your text. This is one I just kind of made up. I thought it'd be fun to go through. Again, what is qualitative and what is quantitative? So example 1, first names of students in our class, right? So your qualitative data are things like names, attributes, so like qualities, and so on. Your quantitative data, these are numbers, but specifically, they are measures, counts, etc. So stuff that you can actually work with. So first names of students, that person's name is John, this one is Sally, Tom. I can't add those up, doesn't make sense, right? Those aren't numbers. This is qualitative data. The number of pets everyone in class has. All right, so I have 2 cats, I have 2 pets. Someone else may have a dog, they have 1 pet. Someone may have no pets, that's 0. That's okay, that's still a number, right? So we could actually count up how many pets everybody in class has, right? These are counts. So not only are they numbers, but they're actually counts. We could find the average number of pets in class. We could find the total number of pets in class. So this is quantitative data. Everyone's favorite color. So I mentioned this one already, right? Everyone's favorite color. Colors are not numbers. If something is not a number, it's automatically qualitative. So this is qualitative. Eye color, right? I have brown eyes, someone else has blue eyes, someone has hazel eyes, and so on. That is qualitative, right? It's an attribute, right? It's a quality. It's your eye color. Everyone's height, okay? So think about heights. Heights are typically done in numbers, right? You could do it in feet, you could do it in inches, you could do it in centimeters, whatever, right? So it's some sort of number. And then think about that. Could we actually work with those numbers, right? Well, we could find the average height in class. We could add up the heights to see how tall the class is overall. This is quantitative data. F, everyone's social security number in class. Now, this one is actually really tricky because a social security number is a number, right? So if you live in the United States or if you're a US citizen, you have a social security number. It is, let's see, 8 digits long. However, social security numbers, they're really more of a way to name each person or give each person a label in the system. So even though they're numbers, this is actually qualitative data. Okay, and this is why. So if you think about social security numbers, I can tell you that I have 3 children, and they're different ages, so I don't have twins or anything like that. And they have all different social security numbers, of course, but there's no real order to them. So it's not like my younger kids have a later number than my older kids. They're not in a particular order that I can recognize. Um, it doesn't make sense to find an average social security number. They're really a label. So that social security number represents me as a person, right? It's kind of like your school IDs, right? So if you have a school ID that's a number, for instance, or in anything you do, maybe you have a work ID that's a number, that is a label. That's a way to name you. So that's qualitative. The number of pencils each student brought to class today. Well, I have, we'll say pens too. I have 4, so I brought 4. Someone else may bring 1, 0, 10. So these are numbers, but they actually numbers that we can work with, right? I could find the average number of pencils in the class, the total number of pencils. This is quantitative. All right. So I'm going to start F because that one's tricky. H is actually a little trickier too. So let's say I were to split the class into 4 groups, right? So I said, okay, everybody count off 1, 2, 3, 4, and you're each going to go to different corners of the room. We're going to do a group project, right? Well, I'm using numbers, right? I'm labeling my groups. Oh, you're group 1, you're group 2, you're group 3, you're group 4. So I have the numbers 1, 2, 3, 4. But it doesn't make sense to average those together. That doesn't give me a new group. It doesn't really make sense. Um, they're not really meaningful to each other. They just get me to label each group, right? I could have called you guys group A, B, C, or D. I could have called you team blue, team red, team green, team purple. So by me saying, oh, you're group 1, you're group 2, group 3, group 4, it's just a label. So that's another label. Even though it's a number, it's not actually quantitative data that we're going to do calculations. So that's the thing with quantitative data. You need to do calculations with it. They need to make sense. So here, my labeling my groups, group 1, group 2, group 3, group 4, that's a label. That is qualitative. Okay. So some differences between qualitative and quantitative data. Now, why is it important? It's important because it can tell us what we can actually do, right? So there are certain calculations that we do with quantitative data, and there's certain things we do with qualitative data. So for instance, if I'm looking at everybody's, let's say, favorite color in class, I could find the overall most favorite color, right? If 5 people like blue and only 3 people like red, let's say, then I can see that more people like blue than red. So I can see how many are in each category. I could find the most, like which category has the most, but it doesn't make sense for me to find an average. It doesn't make sense for me to find percentages on, well, I shouldn't say that. Hence, um, I guess sometimes we can do percents with qualitative data, depending on if we're counting um, our data, like how many people like blue or how many people like red. So it could work, I guess. Would not work maybe as well for first names, right? Most people have different first names. Occasionally you have a repeat. But it really makes a difference on what kind of data we have, what calculations we can do. So it is important to distinguish what kind of data we have. Now in the next video, we're going to break down qualitative and quantitative a little bit more into 4 subcategories.